class. Good morning everyone. I am Mrs. Rushali Chaudhary, lecturer Praveen Patil Polytechnic. We are going to learn applied science chemistry under the code 22211. We already started electrochemistry. What is the electrochemistry? Conversion of electric energy into the chemical and chemical into the electric energy. When that changes take place or conversion take place, we require some terms. What are that? Conductors, resistance, insulators. But it is going to follow some laws. First, we are going to learn Ohm's law. What is the Ohm's law? The strength of the current passing through a conductor is directly proportional to the potential difference applied across the conductor and inversely proportional to resistance of a conductor. Means whatever the current flowing through a wire is directly proportional to the potential difference across the conductor and inversely proportional to the resistance. It is written as V proportional to the I. I is current, V is potential difference. So V is equal to IR. R is proportionality constant called as resistance. So R is equal to V upon I. Unit of resistance is ohm. Specific resistance. The resistance of a conductor is directly proportional to its length and inversely proportional to the area of cross sections. Ohm's law found that solution of electrolyte offers resistance to flow of current in the solution, and that resistance of a conductor is directly proportional to the length and inversely proportional to the cross sectional area. So R proportional to length and R proportional to 1 upon A. So R is proportional to L upon A. So R is equal to rho LA. Rho is the proportionality constant called as specific resistance. When length is 1 centimeter and area is 1 cm cube, that time resistance is equal to specific resistance, and it is defined as the resistance offered by a material of unit length and unit area of cross section. It's called as specific resistance. It is the resistance of a uniform column of a material of conductor having a length 1 centimeter and cross section of 1 cm square. So unit of specific resistance is ohm dot cm. Ohm multiplied by cm. Conductance. The reciprocal of resistance is called as conductance. L is equal to 1 upon R. It is opposite to conductance. Opposite to resistance. जितना resistance बढ़ेगा उतना conductance decrease हो जाएगा. Okay, as the resistance increases, conductance decreases. As the conductance increases, resistance is decreases. Unit is ohm inverse. Specific conductance or conductivity. Reciprocal of specific resistance is known as specific conductance. 1 upon R is equal to 1 upon rho into 1 upon L by A. So, specific conductance is equal to K into A upon L. K means kappa. Unit of symbol of a specific conductance. Unit of a specific conductance is ohm inverse and cm inverse. The conductance of a solution enclosed between two parallel electrodes of a unit area of cross section separated by unit distance. Equivalent conductance or equivalent conductivity. It is defined as the conductance of all ions produced by the dissociation of 1 gram equivalent of an electrolyte dissolved in a certain volume V of the solvent at a constant temperature. Unit is ohm inverse cm square equivalent inverse. Molar conductance, molar conductivity, it is defined as the conductance of all ions produced by the dissociation of 1 gram of mole weight of electrolyte dissolved in a certain volume of the solvent at constant temperature. It's called as molar conductance. Cell constant. It is a constant characteristics of the cell in which electrolyte is taken, and its value depends on the distance between the electrodes and the area of cross section of electrode. So cell constant is specific conductance multiplied by resistance. These are the terms which is involved when the electrolytic changes take place. How much electrolytic changes take place are found by using these terms. Numerical is not in your syllabus. Variation of conductance with dilution. The conductance increases with increase in the concentration of electrolyte to a certain maximum level and decreases on the further increase in the concentration. This is because an increase in the concentration, the population of free ions increases, and as the free ions increases, they are going to require more energy and conductance is going to increases. Even if the dilution increases, that time also number of cation anion increases, conductivity is increases. That we'll learn in a conductometric titrations. There are followed by the two types of electrolyte, a weak electrolyte and a strong electrolyte. What is the weak electrolyte? Where dissociation and ionization is partially taken. Small amount of salt is converted into cation and anion. That time it is called as a weak electrolyte. Strong electrolyte, where all salt is converted into cation and anion, it's called as strong electrolyte. Weak electrolyte solutions are poor conductor of electricity because they are having very less number of cation and anion. Strong electrolyte which are present in the solution having a good conductor of electricity due to large number of cation and anions. Example of weak electrolyte is weak acid, weak bases like ammonium hydroxide, acetic acid, which are soluble in a water but going to produce very less number of cation and anion. While strong acids, strong bases like HCl, HBr, HNO3, H2SO4, hydrochloric acid, as well as the NaOH, KOH, when they dissolve they will form a large number of cation anions and they are called as strong electrolyte. Degree of ionization. The amount of salt dissolved in a solvent that determines by the degree of ionization. Degree of ionization tells us about a strong electrolyte and a weak electrolyte. It is by definition we will say that the fraction of the total number of molecules of an electrolyte which ionizes in a solution is called as degree of ionization. It is a fraction of the total number of molecules of an electrolyte which ionizes in solution. It's called as degree of ionization. So NaCl when dissolved in a water, it is form a Na plus Cl minus, and at how much Na plus and Cl minus ions it form, that is called as a degree of ionization or fraction of molecules formed. The factors which determine the degree of ionization. How much cation anion form, that is some factors are affecting, like a nature of solute. If there is a strong acid, strong base, number of cation anion is increases. Similarly, nature of solvent means in a which solvent, which medium we are dissolving the salt or we are dissolving the solute. Accordingly, conductance or ionization is changes. Dilution or the concentration. If the concentration is higher, less number of cation and anion form. So, dilution is less, very few cation, large number of cation and anion is form, conductivity increases. Temperature. As the temperature increases, conductivity, dissolution is increases, ionization also increases. So, degree of ionization increases. Nature of solute. If compounds are ionic or the electrovalent compounds like acids, base and salts which get highly ionized in solutions like HCl, NaOH, KOH, KCl are highly ionized in solution called as a strong electrolyte having a high degree of ionization, while acetic acid, weak acid, ammonium hydroxide weakly ionized in a solution, so degree of ionization is less, called as weak electrolyte. Nature of solvent. Polar solvents like water, ammonia have a tendency to separate cation and anions. So, large number of cation and anions produce, conductivity is increases, while non-polar solvent conductivity is low as they are not separating cation anions. Concentration of solution. Degree of ionization is inversely proportional to the concentration. Degree of ionization increases with the increase in a dilution. If we added more water, degree of ionization is increases. But if we add more solute, degree of ionization is decreases. Temperature. The degree of ionization is directly proportional to temperature. If the temperature increases, the molecules of electrolyte is gain thermal energy and they will form cation anion in a large quantity, so conductivity is increases. We are going to solve the MCQ based on today's topic. Unit of specific conductance is mOhms cm inverse. The conductivity of solution is directly proportional to its number of ions. Thank you, class.